Hello everyone. In this video we're going to talk about possibilities, trees, and multiplication rule. So we have a tree and the tree is going to be a good structure for keeping track of all the possibilities that a situation or an event that happens in certain order is gonna happen. So the following example is good for that. We're going to have two teams that are going to play repeatedly each other until one of them wins two games or until one of them just win three games at all. So one way that this tournament could play out is, let's assume A is gonna first win the first game, but then B wins the second game. Then A is finally going to win the second game and the third game. And so because that uh, fulfill one of the conditions for completing the tournament, then we're done. And we can denote that as A, B, A, A. Now, on how many ways this tournament can be played. So notice that we can have up to top of 5 games. Why? Because we can have first that A or B are going to win, and then we can alternate. First, it wins A, then wins B. So this scenario, the 5 games will be first A wins, then B wins, then A wins, then B wins, then A wins. So it takes them up to the last point for them to achieve victory, to have the 3 games. This can also happen with B. So you can have B, A, B, A, B. So this is the 5 games, and this is one way of keeping track of this is, well, the winner of the first game can be A or B in the tree. Then for the second game, again, regardless of the possibility, the winner can be A or it can be B. Let's assume that we go by the top. If we reach that A wins, so we're done because we're in the second game. So that's one of the possibilities for 2 games. 2 games is we have AA or BB. Okay. Now for finishing in 3 games, it means that the second team that was alternating got the victory in a row. So for example, here A won first, but then B won, and so to finish in the third game, we need that B is gonna win again. So we have A B B, or we have the opposite. First B won, and then A won, and then won again. Okay, that's for 3 games. For 4 games, then you have the situation like we have here. First it wins A, then B, then A, then A, or we have the opposite, B, A, and B, B. So we have a total of 8 possibilities that we can use, 8 ways for this entire tournament to be played. As you can see, this structure where we make a tree is very good to keep track of this. But also, you're very good making this kind of list that can also work out for finding those specific ways that the event can happen. Now, question B is, assume that these are all the ways that we have for the tournament to play out. What is the probability that 5 games are actually needed? So the probability of 5 games, of course, is going to be the number of ways that we have 5 games over the total of outcomes. And the total of outcomes is 8. We just found them here. And the total of ways that we get 5 games is 2. So this is 2 out of 8 possible games. Now moving on, let's define the multiplication rule. So the multiplication rule consists of an operation that's going to have k steps. And so in the first step, we can perform this step in N1 ways. The second step then can be performed in N2 ways. And the k step can be performed in Nk ways. So just to give an example of that, or to conclude, the entire operation is going to be the multiplication of that N1 times N2 times Nk. And a quick example of this will be have a pin. Let's say a typical pin or an identification number is going to be any 4 symbols that we can choose. So for example, here I get to pick 1, 2, 3, 4 for my key. And now we're picking from the 26 letters of the alphabet plus 10 digits. So 26 letters, and then 0 to 9 are the digits. So this is a total of 36. So because we can repeat, then we can have 36 options for each of these keys, and the number of possible pins are 36 to the 4. Now obviously we can create complexity with this, and then we can start putting conditions. So now let's assume that we're gonna get pins where repetition is not allowed. So if repetition is not allowed, for the first one I'm gonna have 36 options, but for the second one I'm gonna have just 35 because there is one that I cannot repeat. For the third key, I'm gonna have 34 options because I cannot repeat what I got here or what I got here. And similarly for the last option, I'm gonna get 33, so I don't repeat any of this. Okay, so the final number of options here is 36 times 35 times 34 times 33. Now, of course, this can be put in terms of probability. This is just counting how many possibilities are here, and this is the possibilities of a particular event. So I can actually calculate what is the probability that a pin does not have a repeated symbol, assuming that all pins are equally likely. So this means the probability of a pin no repetition will be the numbers of pins with no repetitions over the number of total possible pins. So as you can guess, this is going to be 36 times 35 times 34 times 33 divided over the total possible. That is going to be 36 to the 4. So again, and this is going to be a number that is less than 1, because notice that each of these numbers is going to be at most 1. 36 over 36 is 1. 35 over 36 is going to be less than 1. 34 over 36 is less than 1, and 33 over 36 is less than 1. So you can get a number that is between 0 and 1. Now, once we have this, then we can make some other type of calculation. So we can address some of the examples that we were seeing before from the point of view of the pins. So for example, we have how many integers there are from 100 to 9099. So if you remember that from the class, we were talking about this being 9099 minus 100 plus 1. And then this is going to give me a total of 900 possible pins, or total integers, sorry. These are integers with 3 digits. And so normally from 0 to 9099, you have 1,000. So from 100 to 9099, it makes sense that I have a 900. Question number 2 says, how many odd integers are from 100 through 999? And so because these are 3-digit numbers, to be odd, I only care about the last one being an odd number. So for the last one, I need to have 1, 3, 5, 7, and 9. So I have 5 possibilities for this one. But I'm gonna have 10 possibilities for this one, right? Since this can take numbers from 0 to 9, and of course, because this one is taking from 1 to 9, then I'm just gonna have 9 possibilities here. Okay, so this is 1 to 9, this is 0 to 9, and this is just this 5 digits here. So if we use multiplication rule from here, we can get that the total number is going to be 9 by 10 by 5. And that's going to be the total of odd integers that I can get. Now, how many integers from 100 to 9099 have distinct digits? So now if I take a look at that from that point of view, I can have 3 different digits here. And so because we have different digits, then the 100 is going to have choices 1 to 9. So it's going to have 9 choices. Here, we potentially can have 0 to 9, right? So normally it will be 10, but because we're not repeating, right? So you're gonna have only 9 choices here. 0 is not one of them, right? So, 0 is one of them that is not gonna repeat with anything here. So that will be fine. And so you have 8 choices more, whichever is different from here. And now for the last one, of course, then I'm gonna have only 8, because you gotta pick from whatever is different from this one. Okay, so you exclude what you got here, and that's the numbers that you're gonna have in here. So that is gonna be around 648 possible distinct digits. Now last, how many integers from 100 through 1999 have distinct digits, but being odd? So again, because we're being odd here, then we only have 5 possible digits here. And then again, this is going to have 8 numbers here and 8 numbers here that are possible. This 8 choices is because we of course can get 1 to 9 here, but not 0, right? And from here, we normally could get 0 to 9, right? But then we gotta remove whatever we have here, and then whatever we have here, since we gotta pick this one first. This one, the either 1, 3, 5, 7, or 9 is gonna go first, so we can have an odd number. So that numbers cannot match this here. Okay, so the total will be 8 times 8 times 5, and that's going to be around 320 numbers. Now we can of course do the same that we did before. What is the probability that normally random chosen 3-digit number has distinct digits? And what happens if it has distinct digits and is odd? So we're pretty much going over the total number of possibilities, which is this here on the bottom. And then we have the 2 cases with either this or this. So distinct digits, the probability of that is going to be 648 over 900, which is the total possible of digits that we have from 100 to 1999. And then distinct and odd, then it will be 320 over 900. Okay. All right, so that is the introduction to the multiplication rule and to trace. On the next video, we're going to see permutations.